Hello everyone. Today I'm going to discuss the last problem of Leetcode Biweekly contest 151, which is permutations 4. So what is the problem? We are given two integers n and k. We have to return an alternative permutation of length n and such that no two adjacent elements are both odd or both even, and we have to return the kth alternative permutation. So let's take one example. So what are alternative permutations? So let's say this is the alternative permutation of length 4, 1 2 3 4, because the two adjacent elements have different parity. So 1 2 have different parity, 2 3 have different parity, and 3 4 has different parity. But if we take 1 3 2 4, then this is not a alternative permutation, because 1 3 has same parity and 2 4 has same parity. So we have to return the kth alternative permutation of length n. So let's take the first example of length 4. So we have 3 4 1 2, right? 1 2 3 4, and we have to return the sixth alternative permutation. So let's try to write each and every alternating permutations of length 4. So first one will be definitely 1 2 3 4. Then the second one will be what? Second one will be 1 4 2 3. Sorry, 1 4 3 2. Now the third one will be, if we take the first element as 2, then this will be 2 1 4 3, and the next one will be 2 3 1 4, 2 3 I think 2 3 4 1. Now if we have to take from 3, we can take 3 2 1 4, and the next one will be I think 3 2 1 4 and 3 4 1 2. Okay, so the sixth permutation will be 3 4 1 2, right? So that is the answer. So how we can solve this problem? So before going to the solution, let's discuss the time complexity. Here n is 100 and k is 10 to the power 15, so it is not possible to iterate over each and every possible permutations. Like if we try to construct every permutations up to a k, that is definitely not possible. So what we have to do, we have to think something in terms of order of n or order of n square. Even order of n cube is also possible. So my solution is order of n square. Now uh, I'll discuss about how to solve this problem. Let's discuss about solution approach now. So first, let's say we like we fix one element in starting element of the permutation. Let's say we fix starting element of the permutation 1. Now what are the total number of permutations we can, alternating permutations we can have of length n? Okay, so let's say n equals to 4. So what are the three elements, what are the different combinations of three elements we can choose? Okay, so you can see that only parity matters, right? So after 1, this could be 2 and this could be 4, and in between there will be 3. So we can shuffle this between this 2 and 4. We can shuffle between this 2 and 4. Let's say n is 5 instead of 4. Let's say n is 5, then let's say this is 5. So we can shuffle between 2 and 4. Similarly, we can shuffle between 3 and 5. So total number of odd elements will, odd index elements will be 2, and total number of even index element will be 2. So total 4 permutations will be possible if we fix the starting element. Now let's say we have, let's say we have a set. Okay, let's say we have a set of all elements. So initially the set will have all elements. Okay, 1 2 3 4. Okay, so let's take n equals to 4, and let's try to construct our answer for n equals to 4 and k equals to 6. Okay, so initially s will be 1 2 3 4. Now let's say we fix the first element. Okay, fix the first element as 1. Let's say if we fix the first element as 1. Now the odd index element are 2 and 4, and even index elements are 3. So total permutation will be 2 into 1. But we have to find the sixth combination. Okay, sixth combination. So this is not possible. Okay, so if we start with 1, we can generate two combinations. Okay, so that is not possible. Now we'll subtract this 2 from our 6. So 6 will be minus 2 will be 4. So now we have to find the fourth permutation starting from 2. Okay, so from 2 the odd elements are again 2, and even elements are again 2. So again 2 into 1. So that is also definitely not possible. So now remaining element will be 4 minus 2. So we can't really start from 2 also. Okay, we can't really start from 2 also. Now we'll try to start from 3. Okay, from 3 there are also possible combinations of 2. Now 2 minus 2 is 0. 2 minus 2 is 0. That means when the our remaining elements will be less than equals to 0, that means our starting element will be this one. Okay, so we found our starting element from 3. Starting element as 3. Okay, now from 3 we have to again go to the next possible combination of 4 1 2. Okay, so this is kind of a recursion. When we will pass in the recursion step, we will pass s, the current set, and whenever we are saving our current element, fixing our current element, we will remove that element from the set. Okay, and also we have to maintain the parity of the last index, because let's say we have fixed our starting element as 3, the next element could not be 1, so we have to take the parity also. Okay, that is the case. Okay, we have to just take the two variables of our recursion. I have solved this problem using recursion, and the two parameters of the recursion will be, the first is the set of remaining elements, and the second element is the what is the parity of the last index we have taken. Okay, now let's jump into the code, you will understand it better. Okay, so this is the recursion. In the recursion also, okay, so another thing we have to take is the remaining elements. Okay, so whenever we are fixing 3, we have to subtract the previous combinations. Okay, so we have subtracted all the combinations of 1 starting with 1 and all the combinations of 2. Okay, so after that we have to pass 2 to our parameter. So the third parameter of our recursion will be nothing but the total number of remaining permutations. Okay, we have to play with the remaining permutations. So three parameters. First one is the remaining element set. Second one is the how many remaining permutations we have to take. So whenever we considered 1 already, okay, so we'll remove all the permutations starting with 1. Whenever we are considering 2, we'll remove all the permutations starting with index element 2. So that's why we have removed 4 possible permutations from this. Now after removing 4 possible permutations, we'll have 2 possible permutations starting with 3. Okay, so that's why we have to pass 2 to our next recursion state. Okay, so 3 parameters, and this is the answer we are constructing. Now if the size of the set is 0, then this is the base case, we'll just return. Now c will be the total number of possible permutations we have neglected. Okay, so for when we consider 1 and we are removing all the possible permutations from 1, will be c will add c plus equals to all the permutations starting with 1, and whenever we are removing 2, we'll just add all the possible permutations starting with 2 to c. Okay, that's what we are doing now. That is the case. I have already mentioned that we have what are the possible permutations start if we fix the starting element. So what are the remaining of odd elements and even elements? So let's say there are n remaining elements. Okay, there are n remaining elements, so then there will be n by 2 odd elements and n plus 1 by 2 even elements. Okay, n by 2 odd element even elements and n plus 1 by 2 even elements. Okay, now if we consider the entire set size as n, then our value will be, this value will be n minus 1 by 2, n minus 1 by 2 odd even elements, and n by 2 odd elements. Okay, I hope you get it. Now that's why we are taking r as factorial of n by 2, because the number of arrangements of 2 and 4 will be 2 factorial. Similarly, number of arrangements between 3 and 5 will be 2 factorial again. So let's say we have 1 2 3 and we have to shuffle all the elements, then it will be 3 factorial. Okay, 3 factorial permutations will be possible. Now this part is for C++ only, because in C++ if we multiply something like 1 is 16, like 10 to the power 16 10 to the power 16, that will not fit into long. That's why we have to take this case. If you are using Python or any other language which has higher limit for long, then you don't have to take this case. You can directly write factorial of n by 2 into factorial of n minus 1 by 2 is greater than remaining minus c. Okay, so this part is only for C++ to neglect the case of integer long overflow. Okay, now if the factorial of n by 2 into factorial of n minus 1 by 2 is greater than the total number of remaining elements, we know that this is the starting element, so we are pushing back I to our answer. Now we have to erase this current element from the remaining element set, and we are recursion s comma remaining minus c, and parity will be I modulo 2 and we answer. So instead of remaining minus c doing this in this step, what we can do is that we can remove this c from here. Okay, remove this c from here for better readability, and to remove c from here also, and instead of adding c plus equals to, we can do remaining minus equals to. That will be better for your understanding. I hope you get it. Now here another part is interesting, is that in C++ if we do 100 factorial, that would be like greater than the long limit. Okay, so that's why we have to find one. If the factorial of I is greater than 1 is 16, we are setting that value to 1 is 16, so that will be maximum factorial of I value. Okay, that's what we are doing now. another important thing, this part is another edge case, is that if the size of n, if the n is 5, then we have to start with odd elements, because if we start with 2, then we will run out of elements. So 2 1 4, then we have to put 3 and 5 back to back. So if n is 5, then our starting element has to be odd. That's why if the n modularity is 1, that means n is odd, then we are saying that the last taken element is even, so we have to take the odd element. Okay, so we are initializing the set, and we are doing recursion of s, k, last, and answer. So I hope you get it. The overall time complexity is order of n here and order of n here. I think order of n, and we are iterating recursion of n steps. So the overall time complexity will be n square. Overall time complexity is our order of n square, which is definitely possible. And n square into, and we are removing some element from the set, so we can say that this is n square log n. Okay. I will provide the link of the code in the description box. I hope you find this video helpful. If you have any doubt in any part of the code or explanation, you can always ask in the comment section. I'll try to reply each and every comment. If you find this video helpful, please like the video, subscribe to the channel, and also share among your peers. Thank you for watching.